the mathematical finance class in the fall, if people are interested in doing that.
How do I write the, I'm going to call it independent study because I don't know what else to call it.
Directed study? Independent study, yeah. Well, we have to fill out a form for that.
So it doesn't need to be on this sheet?
Does not need to be on that sheet, no. Nope, it does not. Let me go. Maybe I do need these.
Dr. Joe, you're doing statistics next semester, right?
Yes. Sorry.
Right here.
Because you have to deal with me again.
That's what I always have to do with you. I've not gone a semester yet that I have not had to do it.
I'm sorry.
I didn't have you at all freshman year.
I don't think you did either.
And Dr. Joe, next semester I don't start classes until 11.
Cool.
No, that's bad because I have 6 a.m. practice, which means that I have practice and then I just have to go back and just sit there and wait.
No, it's
And
a lot
snooze.
And you can sleep, you can shower. I hated going from practice to class.
Okay, so there's. Oh, no, wait, one more. You know, it's never good to start a class with under half of the people here.
So let's play heads up, 7 up, and make everyone else jealous.
Heads up, 7 up. There's not even 7 people in the room.
Heads up, heads up 3 up.
Have one person go around and tap somebody on the head. I think it was Grace who did it. Wow.
Yeah.
Oh, goodness. Okay.
Who else is supposed to be in this class?
Kevin,
Marshall, Kevin,
Marshall, Sam, Kelly, Haley.
Sam, Kelly. Sam. What's up with Sam? Sam never showed up.
He didn't show up to see us either. Dr. Roth called him out. It was kind of funny.
What did he say?
He came in during art class sometime and he asked Dr. Roth a question and Dr. Roth was like, well, maybe if you came to class you would know I answered that.
Yeah, Dr. Roth is hard to get angry, but when he gets angry, I wouldn't say it's Incredible Hulk angry, but you know.
Not fun.
What, Dr. Roth getting angry?
I've never seen it. I don't plan on getting to that point.
You've had me mad at you.
When? Dr. Joe, you can't even play that. You like me.
I know.
You'd be so bored if I wasn't over here busting your chops.
You should be busting my chops. That's your job.
What does this do?
What is today, Monday?
Wait, what? Oh, I didn't even see we had homework.
Yes. So next Monday.
Due on Monday.
When is our next test? They scheduled before
That's
they...
like right before Thanksgiving.
Okay.
Okay. So Monday. Really, Monday?
Tuesday, yeah.
Tuesday, Thanksgiving, I do. Doesn't mean nothing.
So is today Monday?
Yes.
The 4th?
Yes.
It's 11. It's November, everyone.
The probability is the week before, I think.
Probability usually the week before.
Well, I know I have people in both classes, so I was trying not to do it at the same time.
Yeah.
All right, now erase the homework.
Now erase the homework before Haley gets in here. Okay.
Dr. Joe.
Oh, did you not write it down yet? Crap.
No.
Well, now I forgot what it was.
Just hit the back button.
Oh, yeah, I just hit undo, right?
It's underneath the homework.
Oh, there it is. Thanks. Yeah.
This is all in the big packet?
There we go. No. The The big packet's the first set of problems that I gave you. So this is big packet. This should be big packet chapter. I need to tell you what chapter. It's chapter 11.
What's 5.5?
One of those the one that I gave you last time, or what I just gave you. What I just gave you.
5.5.
I just gave you 5.5.
There's only 4 problems in 5.5.
It must be 5.7 then is what I'm looking at. Hold on. Hold on. Yeah, it's 5.7, sorry.
Is that DE? 5DE?
Oh yeah, because that's the name. The section title is 5D and 5E. I was just too lazy to write it all out. No, next time I teach this course, I'm just going to make the students have to work a review manual. I think it's just easier. So the next time I teach the course, I'll just do a review manual. I think it's easier. Theory of commutation, 2 o'clock to 3:15 Monday, Wednesday.
So would I be in that class?
Theory of commutation, only to do the CS track. So you can be. It's all the only prerequisite is discrete.
Is there 12
You
problems?
don't even have to take like.
I'd rather be in the math group.
Marshall!
What's up, Dr. Joe?
You need to talk to me about picking up pizza tomorrow.
Yeah,
Okay,
I can see you after properly.
there you go. Yep, let's not forget, because, you know.
Yeah, I have a math center meeting at 10 o'clock anyway, so I'll
Okay.
get this on.
That's fine. I just want to make sure that we have it all taken care of, because they need the tax exempt form and the credit card,
Need it all?
and make sure that you bring back an itemized receipt, because otherwise we get yelled at. So they just have the pizzas listed out individually on it.
Really?
Yeah, I don't really give a crap if they write it on a Del Carmen's napkin.
Hey,
but-
Sam's alive.
No. But we get yelled at if it's just a credit card receipt. We have to have an itemized receipt to go with it.
I had no idea.
Yeah. All right. Yeah. They get rather testy about it, and I don't know why. They also get rather testy if we pay sales tax.
And if they're sketched out by Del Carmen's, they can go over there and try Del Carmen's.
Yeah, they could.
Sure, a lot more money to be going there.
It's true. All right. Any questions about the loan stuff before we go to internal rate of return and net present value and dollar weighted return and time weighted return?
That all sounds very confusing.
I know, it's not really though. It's really pretty straightforward.
That's cool.
Mm-hmm. All right. So, just to go through this with an example. All right. So, the investor is going to put out $1,100 right now, and then in return, we'll get $500 next year and $700 the following year. And it asks us to find what's referred to as the internal rate of return. That's what IRR stands for. So, pardon me. Just to write that down. So IRR is the internal rate of return. Basically, it's a return, it's the interest rate, it's a yield on the investment here, right? This investor is putting up $1,100 of his or her hard-earned money. And in return for that is promised to get back $500 in 1 year, $700 in the second year. And this internal rate of return is what yield percentage they're getting per year, or what interest rate is essentially being, I'll say, charged here, or I'll say earned, even better. Okay. So as far as the internal rate of return goes, you can find this by setting up an equation. I know what this value is now. I can move these back and figure out what those values are now, and they better have the same value, right? We've done problems like this, haven't we? Okay, so this $1,100 right now has to be $500 in 1 year and $700 in 2 years. So we would have a quadratic to solve, which we could do by hand. This one would require the quadratic formula, I'm pretty sure. If I remember correctly, I didn't actually do it recently. But I think you have to use the quadratic formula to get it. You'll get two roots, only one of which makes sense. So you'll be able to figure out what the interest rate is. However, there's an easier way to do this. At least if you have your calculator, there's an easier way to do this. So notice on your calculator, right below the down arrow button, there's an internal rate of return button on there. We don't want to hit that yet, but that's the button we're going to use to calculate internal rate of return. The one right next door, the NPV, is net present value. We're also going to use that one today. But we have to do something else first, and I think we've talked about this worksheet before. The CF button here is your cash flow worksheet. So if I hit that, I don't have anything stored in it, but if you do have something stored in it from previous work, right above your clear is clear worksheet, CLR work. So much like when we did the clear time value of money, we're going to do the same kind of thing here whenever we go into the cash flow worksheet. So do second clear worksheet. All right. So what this allows you to do is put in cash flows at certain times and then have frequencies associated with those cash flows. So we'll do several examples here to show you how this worksheet works. Well, the CFO is your cash flow at time 0. Okay? So we have to also keep track of plus or minus signs here. We need to think about money going out, money coming back. Okay? So in this case, the investor is investing $1,100. So if I think of it from the investor's point of view, that investor is going to put out $1,100. So we think of that as negative, right? Okay. So we'll type in 1,100, make it negative, and hit the Enter key to put it in there. And I can tell you one thing that I do a lot and get frustrated by is that instead of hitting the Enter key, I hit the cash flow button, so it goes back to 0, and I get very, very irritated. Because I hit the wrong button, and it makes me angry. There's another word I'm thinking of, but I'll use angry because I know that Haley chewed out Grace for language earlier today. All right. To get to the next cash flows, we use the down arrow. So this says cash flow 1. So this would be the cash flow at the next time period increment. Right now we're doing time period in years, but we could do this in months or quarters or what have you if we keep track of what the time increments are. But as soon as you set the first time increment, every time increment past that has to be the same time increment. Okay? So if I do a cash flow in a month, then I need to make sure that every other cash flow is monthly. Which means that if you had something say the first month and then the 6th month, you would need to make sure that you put in zeros for months 2 through 5. That's why I'm making a big deal out of that. And we'll see an example of that here in a little bit. Okay? All right. But then this is, if we think about putting the next cash flow, and the next cash flow is $500 in 1 year, right? And that's what's going to come back to the investor. So we'll make that 500. Hit Enter. Notice that you go down to the next key. Your initial cash flow has no frequency associated with it. It's just the initial amount that you're putting in at time 0. This frequency, if you had multiple cash flows of the same amount over several different time periods, you could change that frequency to be more than 1. Okay? So if you had monthly time flow, cash flows of 100 for 6 consecutive months, you type in 100 for the cash flow and then say frequency 6, so it repeats it 6 times. And not have to type in 6 individual cash flows in. Okay? All right, so but this was only a 1 frequency cash flow. So we'll just put in 1. The next cash flow is 700, still positive. Make sure you hit the Enter, because otherwise it won't get in there. And then frequency once. Now, if I scroll down again, notice it says the third cash flow is 0. The next cash flow is, or excuse me, the next frequency also says 0. If I don't change that to something else, meaning leaving it at 0, that's the last thing it'll recognize. It'll go back to the beginning. So if you want 0 cash flows, you do have to change the frequency to something other than 0 to get it to go to the next cash flow. Okay. Once it has 0 cash flow, 0 frequency, it just cycles back to the top. Okay. So if for some reason you need to put a 0 cash flow in there, make sure you put a 1 in for the frequency. At least a 1. You have more than 1, but it has to be something other than 0. Is that okay for getting all that entered into the calculator? We okay with that? Okay. So now the last part's easy. I hit internal rate of return and I hit CPT. And I'm done. 5.67% is the internal rate of return. That makes sense? All right. What this internal rate of return says is that, well, how did we come up with this internal rate of return? We equated our present value of $1,100 with the present value of the two payments. Okay? So if we equate those two things, if I think about all those cash flows being put together, put out $1,100 now, get $500 back at time 1, $700 back at time 2, that says that the net present value in that case would be 0, because those two things, they balanced each other out, right? So the internal rate of return is the value that makes your net present value 0. Okay? So what this along with net present value is used for is to evaluate projects that companies might want to take on. Do they want to put out and invest this much money, anticipating these other cash flows in it? Does it make a positive sense for them? What I mean by that is, for example, let's say we wanted to do net present value instead. Click over to that. So when you're calculating net present value, so I have the same cash flows stored in there, right? Didn't change the cash flows. When we do net present value, you're trying to figure out, is it worth my effort? Is it worth my money to invest now to get this anticipated cash flow in the future? That's what you're trying to evaluate with net present value. So let's assume that the interest rate, I don't know, just pick a number. How about 4? Let's assume that the interest rate, you anticipate to have a 4% return. Maybe that's what the market tells you. Maybe that's what past experience tells you. But you say you expect a 4% return. Scroll down, net present value, hit compute. So in this case, it says that, that's interesting. Now, I would have expected the net present value to be negative. Maybe it's because of the ways I have the signs in there. Should it be negative? Well, the interest rate we came up with to start with was over 5. So if I put in a less interest rate, I shouldn't have gotten as much money back. Right? Let's see. If I would have taken 500, oops, let's clear out of this. 500 and divide by 1.04, and then add 700 and divide by 1.04 squared. Interesting. Why am I getting? Oh, no, I know what my problem is. I should have gotten positive. Yes. Okay, sorry. I'm thinking about it backwards. I put in a 4% interest rate. I got a net present value that was positive. Pardon me. What that's telling me is that, what is it? No, it's still backwards to me. Because the idea is it worth $1,100 now to get $500 Oh, yeah, okay, that does make sense. Sorry. My brain's not working correctly. All right, so think of it this way. The point is it worth $1,100 now to get a guaranteed return of $500 in a year or $700 in 2 years? Right? So if the 4% interest is what I could get if I just put the $1,100 in the bank right now, right? That's what I'm thinking about the 4% interest. If I just put the $1,100 in the bank and put it in there at 4% interest for 2 years, I could get a certain value, right? The other option would be to put $500 in the bank at time 1, let it go forward for a year, and then get $700 in 2 years. Which one would have more money? Well, in that case, if I take the $1,100, I mean, I kind of make, if I just do it that way, let's think about it that way. If you take the $1,100 and, oops, that's not 1,100. If I take the $1,100 and move it forward 2 years, I get $1,189. So just looking at the cash flows in particular, is it better to stick the $1,100 in the bank or make this investment? If I stick the $1,100 in the bank for 2 years, do I make as much money as if I make the investment? How much do you make? How much money do you get if you make the investment? $1,200, right? 500 times 1, 700 times 2. So is it worth your money to make the investment? Yeah. So if the net, what it turns out to be is if the net present value is positive, and the reason I was confused to start with is I was thinking about the problem backward. If your net present value is positive, then it's worth your while to make the investment at a particular market rate. So if the market rate says it's 4%, then yeah, it's better because you're getting a better rate of return than 4% if you make the investment. Because we came up with 5.67-ish. Yeah, Grace.
So why did we get a 27.95 if the difference between 1,200 and 1,189 is not?
Because that's interest parts being factored in there. I didn't move the 500 forward the year, right? If I take the 500 and multiply it by 1.04 and then add the 700, there's 1220. And then if you take the difference now, you should get what? It's a slightly different number.
It's just about, but it's like just off.
That's because because we're at 2 different times. The net present value is at time 0. This would be at time 2. So the just off should be the interest rate. That's what's going on. That's why the numbers are slightly different. Okay. But the idea here is that the investment, if your net present value is positive, then the investment in the cash flows is better than what you could get if you just put the money in the bank, so you want to make that investment. Versus if we would have gone the other way around, say instead of 4%, I did 6%, and I computed the net present value, I get a negative, which is telling you, no, it's a worse deal to invest in the cash flows. Just save your money and stick it in the bank. All right? So net present value positive is make the investment. Net present value negative means don't make any investment.
So when we put in our CF, it's supposed to be negative?
The cash flow should be negative. Yeah, the first cash flow, because you're putting out the money and then getting money back. All right. I don't even know what those other ones are. Oh, it's net future value. I don't know what PV stands for. Or DPV. I don't know what those other things stand for. You don't use them for this actuarial exam. You only use the net present value. All right, let's do another one. We could have done the previous problem. What's wrong?
She was like, you said, let's do the next problem. She was like,
Oh.
I was getting up. I needed some momentum. Like, of course. Yeah.
So the previous problem we could have done by hand and not needed the calculator because the equation that we had was quadratic, right? This one's going to be cubic, so it'll be a little bit more difficult to do that by hand. Not impossible, but more difficult. And of course, you can imagine these getting even more difficult and not being able to do them by hand at all. All right, so we've got $11,000. And you get a promised return of $4,000 after 1 year, $5,000 after 2, and $4,000 after 3, and find the internal rate of return. Again, the equation would look like the $11,000 is invested now. You get $4,000 after 1 year, $5,000 after 2, and $4,500 after 3. So that would be what your equation would look like if you were trying to set the two equal to each other and solve. Are we okay with this equation? I mean, I know I did it quickly the first time. Does the equation make sense though? Okay, cool. Because again, if you're taking the exam, they might be asking you to set up a formula rather than just asking you what the answer is. So even though we're going to take this with the calculator in a second, it's still important to know how to set this up. And not just this type of problem, but any type of problem. All right, so let's flip back over to the calculator then. Cash flow, clear the worksheet. I'm going to put out 11,000. So we're going to make it negative and hit enter. Scroll down. In 1 year, we're going to get a single $4,000 payment. In 2 years, you'll get a single $5,000 payment. In 3 years, you get a single $4,500 payment. And again, cash flow 4 here is 0. Frequency 4 is 0. So I'm going to hit it down one more time. Sorry. Hit it down one more time, it cycles back to the beginning. Are we okay with it? Yeah, Grace.
Is our I here, or our IRR equal to the I that's being used in B?
Yes. Yep. That's exactly right. And we're just using the calculator to solve for the I instead of having to do it by hand.
Cool.
Click over to IRR and hit compute.
Back to our
Okay. You shouldn't have. Is that your first number? Did I type the numbers in right?
I got the same thing.
Say, okay. 4,000, Grace?
Yeah.
1.
Yeah.
5,000 and 1. And 4,500. Is that it? Okay. Did you do another 4,000? Yeah. Okay. So about 10.7545. Okay. And again, what this says is basically you're getting a 10.7% return on your investment per year overall. So again, if your market rate is below 10%, below this value, you would want to invest. If it's above that, if the market rate's above that, then no, you don't invest. Yes, Sam.
If the worst way, sure, if it was like 4,500 in the second year and 5,000 in the third year, could you use the geometric series?
If I had 4,000, 4,500, and 5,000, that's going up arithmetically. So you could do it that way. It would be an arithmetic annuity. You could do it that way. Yeah, you could do annuities this way as well. I think they do that. Let's see here. Here we go. This one looks exactly like an annuity. This is number 3. Oops. Ooh, hey. Try to make it a little bigger. This looks like a loan problem, doesn't it? Especially since it says a lender makes a loan. So there's actually 2 ways we can get the internal rate of return on this. One is just to set it up like we've done before, right? Using our ideas with loans, how can we set this up?
Equals 8,000 B.
Okay.
Oh, well, yeah, times like 1 plus
Times What do you want me to do?
Well, I was gonna do like the corner algorithm instead.
Oh, okay. I was going to use other notation, but okay. Well, tell me what you want to do. You want to do it like this?
We're gonna use like the. Okay, I got you. Like the annuity.
Yeah.
Okay, so like the A. Like garage 3.
3. You say garage.
And then you don't know the I.
And then you don't know the I. All right, good. I like garage.
I've heard bracket.
Bracket.
That's what we say.
No?
No, angle.
Angled.
I like garage. I'm going to start saying garage.
It looks like it's in a garage.
It does. I agree. I like garage. This is how we would do it before, right? So you could do this again with your calculator and use the time value of money buttons, right? We would put in, if I clear out of here, clear time value of money, you would put in 8,000 for your payment, 20,000, make it negative for your present value. Really, that which one's positive, which one is negative doesn't matter for that. There's 3 payments, and we would compute the interest rate. Is 9.7?
Yeah.
Is that what you got? Yeah? All right. So this would be how we would set it up with loans, but we could also do it with our cash flow worksheet. And the reason I want to do this is not only because I want to do this, show it with the worksheet, but I want to show you how to use that frequency button, mainly the frequency entry. All right. So this again is $20,000 put out at time 0. Then we're going to have $8,000 come in 3 times. So I'll change the frequency to 3. Does that make sense? And then I should be able to go to internal rate of return and get the exact same number. I better get the exact same number. It's because it's the exact same setup. So all I did was just use the cash flow worksheet, put in the 20,000, 8,000, and 3 for the frequency, and computed the interest rate, which is essentially what we did in the other buttons, isn't it? Just different spots, right? We put the 20,000 into the present value versus cash flow 0, put 8,000 in for payment versus cash flow 1, put 3 in for n as opposed to frequency. It's just a matter of which way you look at it. My thought would be is if you've got the same level payment every time, I would probably just keep using the time value of money button. Use the cash flow if you've got changing payments.
I feel there's like way too many payments put in there.
So that's a good question. On your normal calculator, you've got 24 slots that you can put in cash flows. And in the professional one, which is what this is, the BA2 Plus Professional, there's 36. It's got a little bit more memory.
So what do you do if you have too many?
You probably should have set it up as an annuity to begin with. Yeah, it won't need it won't have too many.
I mean, I was just curious.
Yeah, you would have to set it up a different way.
Right.
There was one, I was looking at another textbook looking for example problems. And it said, you can't do this on the BA2 because you've got too many slots and you'd have to do it for one's like, no, you're just doing the problem wrong. You can do it this way. And I did the problem and got it the same answer they did. And use the cash flow. So I'm like, no, you're just setting it up wrong. The way you set it up, you can't do it, but you can set it up a different way. You're wrong.
I should get all the credit.
No, you can set up problems where you can make it where it won't work, but the idea was that it was some payment. You had some payments at some times, and other times you didn't have payments, so it was alternating back and forth. But all you have to do then is just change your time period. Instead of finding a monthly interest rate, maybe you find a 2-month interest rate. So, all right, we okay with this one? Yeah. Let's look at another one here. All right. So this one starts talking about time-weighted and dollar-weighted returns, but I want to do the internal rate of return first to show you how you can play with those frequency buttons. That's the whole reason why I wanted to do this. All right. Okay, so when we're doing internal rate of return on these amounts that are going in and out of an account, we need to keep track of when the cash flows are and see if we can get well, in this case, a monthly rate. It looks like things are going by months here, right? And then change that monthly rate to a yearly rate. And then talk about how we don't really do that and we use a different estimate instead. Okay? All right. So we've got $100,000 put in at time 0, right? And then we've got $10,000 taken out at time 1. Because it says February 1st.
What about the 2,000 that dropped?
Yeah, well, we're not using that right now. I'm just worried about the flows. This is telling you something about, basically this tells you something about what the market's doing, going up and down. That's where we're going to get to the time weighted. So we'll talk about that in a minute. So I'm not worried about those balances right now. So we put in 100,000, we took out 10,000, so that's like we're getting paid back again, right? That's at time 1. Nothing happened at times 2 through 8. Oh, sorry, 2 through 7. Everything's off by a number, right? February is the second month, but it's at the beginning, so that's actually time 1. So September, this would be at time 8. This is at the beginning of September, at the end of the 8th month. Okay. So something happened at time 1, nothing happened at times 2 through 7, something happened at time 8, nothing at 9 and 10, or 11, and at the end, we're going to take out 105. Right?
Why are we taking out 105?
To get the internal rate of return, that's what we're going to get back out. We're thinking of it as cash flow coming back to us. We put out money at the beginning when we get cash flows back. Yeah, really.
So for this one, would it go up to 13 instead of 12 since it says that year-end the account balance was 105 and it like switches?
We're doing, at the year end, that would still be time 12 because this was time 0. So there's still 13 ideas there. Yeah. All right, so let's see how we would put this in the calculator to get internal rate of return. And then talk about why we'll never do it this way and use an approximation instead. Okay? Don't you love when we do that? All right, clear our worksheet. 100,000 to start with. At time 1, we took out 10,000. So I'm going to make that positive. We're thinking about investing the 100,000 to start with, and we're pulling out 10,000. So it needs to have an opposite sign. Does that make sense? Okay. That's one time we're going to do that. Then we've got a 0 amount that we're doing. So let's see, we just did February 1st, right? March 1st, April 1st, May 1st, June 1st, July 1st, August 1st. Nothing happened, right? Okay, so we'll have a $0 cash flow for 6 months. I need to change that frequency to 6. Right? As soon as I did the first one for January 1st to February 1st for 1 month time, then every other cash flow has to be per month. That's why I have to put in 6 zeros now. Okay? The next cash flow was a new deposit of 10,000. So should that be positive or negative? We're going to do a new deposit. Or it should be negative, right? Because we're taking money out of our own pocket and putting it in again. Right? So 10,000 negative. One time. All right, now we're at October 1st, November 1st, right? December 1st. So that should be 3 more zeros. I'm doing this right. And then the very, very last one, we should get $105,000 back. And that'll be positive because we're going to take it out of the account. Okay. Now we should be able to compute our internal rate of return. We give 0.4322, but that's an interest rate per what? Month, right? So if I want this, I need to, and also this is, just like everything else, this is a percentage, not a decimal, right? So the first thing I have to do is divide it by 100. Add 1 to it. Raise it to the 12th power. And subtract a 1 from it and get 5.31%. Phew, that was fun, wasn't it? Yeah. So this is how you would do it if you actually wanted the honest-to-goodness internal rate of return. Actually finding the interest rate that makes this changes exact. Okay? But notice that we're only doing this over an entire 1 year, correct? So if we ignore the withdrawals and the deposits and just worry about the $100,000 sitting in the account for 1 year, simple interest and compound interest per year, same exact thing, right? If I have an annual percentage rate that's compounded yearly, that's the same as just doing the simple interest for that same year. Okay? So to get this, what's referred to as the dollar-weighted rate of return, we're just going to assume that everything is simple interest and calculate the interest rate. And it gives us an approximation for the internal rate of return. Okay? So dollar-weighted return assumes simple interest is earned on the investments. All right. So let's think about how the formula comes about and then see what has to happen. All right. So we know we start with $100,000. That sits there for 1 year and it will grow, right? So this is our accumulation factor for simple interest, right? 1 plus IT, right? So that I sits on there for a year. And this is the investment, so I better, no, that's okay. I don't need to make it negative. It'll come out negative here in a second when we do the solving for the I. All right, so what else happened? We had a withdrawal of $10,000 on February 1st, right? So we're going to subtract off the $10,000. Because we're going to lose the interest on that $10,000 over 11/12 of the year, right? Because we did this we did it at February 1st. Does that make sense? We're taking out $10,000, so we're going to lose that $10,000 plus any interest that $10,000 would have accrued. So that's why we've got the 11/12. And then at September 1st, we're going to put $10,000 back in, and that's going to accrue interest for what? September, all of September, October, November, and December, so 4/12. Right? Everybody see where that's coming from? At the end, this needs to equal, $105,000. Yeah, Grace.
What are we gonna use that $98,000?
For the other one, for the time weighted.
What are we doing right now?
We're doing dollar weighted. Okay, so dollar weighted, your dollar weighted rate of return is an approximation for your internal rate of return. Time weighted is also an approximation. It's just that the dollar weighted is specifically using simple interest, where time weighted is going to use growth factors. And we'll probably talk about that Wednesday because I've only got a couple more minutes. Okay. And I want to get to the formula here. All right, so if I want to solve this for I, notice first I need to move all of these initial deposit withdrawals, deposits over to the other side, right? We agree? When I distribute that through, they'll all have to get moved over. So you'll have 105,000. Let's move this over a little bit. 105,000 minus 100,000 from this one, right? Notice this shouldn't be too big of a surprise. This is ending balance minus beginning balance, right? So what we're going to have on top is actual interest earned. I'm not done yet, but that's what this looks like, right? I'm taking where I ended and subtracting off where I started, right? That looks like how much did it grow, correct? But now I've got to worry about what did I put in, what did I take out? Well, part of this $105,000 is this $10,000 that I put in, so I need to subtract it out. Also, out of that $105,000, I actually took out $10,000, didn't I? So I have to add it back in. So what we have here is we have ending balance, beginning balance, deposits, withdrawals. So you take your ending minus your beginning, you subtract out all the deposits, you add all the withdrawals. That's what the formula looks like. Basically that is an actual, honest to goodness, how much interest did you earn, right? That's the difference between what you put in the account and what you got back out. That's an honest to goodness calculation of the amount of interest. Now I want interest rate. What do I need to divide by?
94166.666.
Okay, well, let's talk about how we got it. Here's your, I got beginning balance on the I, right? Right? I got a minus 10,000 times 11/12 on the I, and a plus a 10,000 times the 4/12 on the I, right? So on the bottom, we've got the 10,000, 100,000, sorry, times your 1. You've got minus the 10,000 times the 11/12, and plus, oops, that was weird. Was to hit desktop. And then plus the 10, that was really weird. Plus the 10,000 times the 4/12. Those make sense if you think about it, right? These are the cash flows that we have and the time they sat in the account. Right? We agree? Right? So if you go through and calculate this, what do you get?
I got 0.0509.
0509, is that what you said?
05309.
Oh, 309. Well, that makes more sense. Good. It's almost the same. Yeah, it's very, very close. Because what did we get for the internal rate of return when we calculated it earlier? 0.0531, didn't we? And if we would multiply by 100, the decimal place will be a little bit different at the end. But the idea behind this dollar rate of return is we're using simple interest to approximate the return versus the actual internal rate of return. Makes the computations a little simpler. That okay? The process isn't bad, right? On the bottom, what you'll see in books and review manuals, you'll see this what kind of looks like a nasty sum formula, but it's in terms of cash flows and times. You'll have like a C sub t times a 1 minus t or something along those lines. So it's a cash flow at that time. The 1 minus the time is how much longer it sits there. So you'll see the formulas written that way. But if you just go through and think about what you have to have, I think it's just easier, personally, as opposed to trying to memorize the formula. All right? Enjoy.
Enjoy.
I think I was trying to say something different today.
Enjoy.
Oh. Did I not set one here? I'm sorry. Sorry, here you go. You're welcome.
Dr. Joe, did you figure anything out yet?
I just said,
Theory.
I go.
Yes, it's got changed to 2 o'clock. Monday, Wednesday. 2 o'clock, Monday, Wednesday.
And Friday?
3:15. Nope, 2 to 3:15, Monday, Wednesday.
Okay.
Not Friday.
Thank you.
Yep.
I'm not even gonna after work. It's got a lot of eyeballs.
Whoa, Dr. Joe, are those labels?
What?
On the screen. In the different
Where?
sheets. Are those labels?
Where?
Where it says.
Where? Who?
Dr. Joe clearly didn't prepare for today. Somebody else did.
Yeah.
Because he doesn't use labels. He prefers to just do the guess and check method.
Make all the labels?
What labels?
No, I did it.
Oh, okay.
I did it.
I thought she was trying to fancy.
Yeah, she was kind of sounded that way, but no, I did it. She's just being a snot. It's
For
fine.
what it's worth, Dr. Joe, I don't see any labels up there.
You know what I'm saying? Thank you, Marshall. I appreciate the support. Oh, wait, I forgot to hit stop.